In this video, hazards will be discussed. Generally, hazards are an unwanted switching transient that appear in the circuit because of the different paths and different propagation delays that was. These hazards will occur in the combinational circuit, which causes an temporary false output value, and sequential hazards, if there are any hazards occurs, it will give the wrong stable state value. So as of now we discuss hazards in combinational circuits. We can say hazard is a condition which change a variable or momentarily in the output. That change should not occur, so that is an hazard. So hazard, there are three different types of hazard. One, it is static hazard, static zero hazard, static one hazard, and dynamic hazard. So static one hazard, it is a hazard where the output should remain constant at 1, but due to some unwanted glitching it goes to 0 and come back to the 1. So static 0 hazard, here the output should remain as 0, but it goes to 1 and come back to 0. It is static 0 hazard. Dynamic hazard, where the output changes from 0 to 1 or 1 to 0 for 3 or more times, they are said to be called as dynamic hazards. So consider this function, a function f is equal to a b prime plus bc. So for this we have drawn a k map. So in this, static one hazard will occur. So let me explain how this. When we are changing the values of a and when we are changing the values of b and d, the output f always should be remain at 1. But if you see the timing chart, the output will switches to 0 between the periods of 40 nanoseconds and 50 nanoseconds, where that should be remained as 1, but it goes switches to 0 and go back to 1. So this switching of 1 from 1 to 0 should not be occurred. So this is a static hazard. So we can eliminate the static hazard by combining these two SOPs. So previously it was a b prime plus plus bc. By combining those SOPs with the term of AC, the unwanted switching can be eliminated. So this is how we can eliminate that is the nearest possible adjacent grouping should also be done. That is the basic concept behind eliminating the static one hazard. So likewise, static zero hazard, this is a circuit. For the circuit we have marked POS. So these POS, so these are also due to the propagation delay and unwanted wiring concept present here, the static zero hazard will occur. So in timing diagram, if we see between the periods of 15 to 18, there is an unwanted switching of the output from 0 to 1. So this should not be there, it occurred. So we can eliminate this unwanted switching from 0 to 1 by the grouping. So previously there was 3 grouping. So now we have grouped the possible groupings. So all those things were grouped. By this grouping, static zero hazard can be eliminated. That is the primary implicants that are present in the adjacent zeros, that was not covered already, but it should be covered with a common loop. So by covering with the common loop, or all the possible combinations should be mapped. So by mapping we can eliminate 0 hazard or 1 hazard. So static 1 hazard, if existed, if there are two adjacent cells on the map, you should also include 1. And also static 0 hazard, also same concept. If there is any combinations that it also to be mapped. Dynamic hazard, it is a different hazard where there is a switching transitions from 0 to 1 or 1 to 0 that occurred 3 or more times. So the conditions to be satisfied if dynamic hazard exists are: there is an adjacent combination on the corner map with have a value of x and alpha equal to 1 with an opposite functional values. This is the first one. And the second, it is most important, that is the x should be propagated towards 3 different paths through the circuit. In order to make the output, it has to traverse through the 3 different paths. This is one circuit which has hazards, dynamic hazard. So the circuit and the corresponding POIs were given here. So the same concept here. So we are combining all those adjacent possible cells. So by these cells, the hazards can be eliminated.